What's up, what's up? It's Miss Tryan. I'll be doing the videos for this unit. We're going to start with inequalities. So this unit should take us about a week or so. Nothing too terrible. It's pretty similar to solving equations. So if you did well there, you'll probably do well in this one too. Alright, so let's go ahead and get started. So today we're going to read inequalities, symbols, and statements. It's going to be our big objective for the day. Our booklet does look a little bit different, but that's mainly so you can pace yourself and see what you have and have not done. Alright, so let's go ahead and get started. Alright, zoomed in. Alright, so let's go ahead and go to the definitions and the terms that we're going to be using throughout this entire unit. So I'd say these are the pretty most familiar ones that you may or may not know, but you will know by the end of the unit. So the first one, let's go ahead and get started with inequalities. So an inequality is a relationship. Oh, look at that great handwriting. Let's try that again. Is a relationship between two expressions that are not equal. That's the biggest difference between equations and inequalities, is these two are not equal. So our example here is we have x and 100. You're comparing those two with that inequality symbol. So x is less than 100, but it's okay if you don't know that because we're going to talk about that here soon. All right, our next definition is a number line, which you'll pretty much be using every day until the end of the unit. So a number line is just a line where each point represents a real number. A real number. Gonna use the number sign, not the hashtag. So it's pretty much just a visual representation of that numerical value. Over here's a small example of our number line, but you'll be a pro at writing them by the end of this unit. Alright, our next one is one-step inequalities. So that is only doing one operation to find the final answer of the inequality. So we know that could be addition, subtraction, multiplication, or division. So there's our little symbols here. It's just doing those operations. Our next term or definition is two-step inequalities. So this is similar to one step, but you're doing two operations rather than one. Two operations. Look at that. Fantastic handwriting. So here's our example over here. Like I said before, it's super similar to solving equations. The only difference is this inequality symbol. Normally there'd be an equal sign there, but nope, it's going to be an equality. All right, and then lastly, we've got our compound inequalities, which we'll be doing later in the unit. And that's pretty much just saying two or more inequalities that are written together. Because they're best friends. So if you look over here, we've got -2 and 3, and we're just seeing that relationship within x, that it's between those two. So like I said, we'll touch on those a little bit later in the unit, but let's go ahead and get started on the foundation of this entire unit. So we're going to be interpreting inequalities. Alright, so our first one, we've got less than. Okay, that's how we say it, and that's the symbol that we'll be writing if something is less than something else. So for our example over here, we've got x must be less than 3 if it says x and has that symbol. So x is less than 3. Our next one, we've got our greater than sign. There's our greater than. And that's pretty much saying that something has to be greater than something else. So our example is x is greater than 4. Our third one, we've got less than or equal to. How we know it's equal to is that line under it. So if you see that line under an inequality, that's when you know you'll include your equal to. Okay, so this one is just saying that it's less than or equal to some other number. And then lastly, we've got our greater than or equal to. Because it has that line, it includes our equal to. So for our example here, we've got x must be greater than or equal to 1, because that's our inequality written at the beginning. Alright, so let's just talk about some video games real quick. I compare inequalities to Pac-Man. Okay, Pac-Man looks kind of like an inequality. The only difference is it doesn't have that circle, but hey, you can make each one an inequality if you want to really have fun with it. Alright, So that kind of helps us out. If you think of it as Pac-Man, Pac-Man wants to eat the bigger number. He's a hungry Pac-Man. He's got to get all of his nutritions for the day. So he wants the bigger number, not smaller number. Nobody needs that. So if we look at this examples down here. So we've got 100 and 200. Okay, well, Pac-Man needs to face the 200 because it's saying that it's the greater number. So, but in this example, 100 is less than 200. Okay, so because the Pac-Man's facing the 200. For our next example, we've got 12 and 10. Well, 12 is greater than 10 because the Pac-Man's facing the 12. For our third one, this is a little different just because it's the same number. But look at our inequality. Let's compare it to our top chart. It's the greater than inequality. So 13 is greater than or equal to, because it has that line, so remember equal to. And then lastly, we have 16 and 32. Well, we know 32 is a lot bigger than 16. So 16 is less than. But look, oh snap, there's a line under it, so, or equal to. So make sure you include that equal to. Okay, that is necessary if that line is under it. So that's pretty much just reading some basic ones, but let's keep going and tackle some where we have to fill in the blank. So, oh snap, look at those 4 examples. Let's do them. All right, so let's change our color to red, because why not? So we got 4 and 5. We know our 5 is bigger, so we want our Pac-Man to face the 5. So when we read that, it just says 4 is less than 5. Okay, for our second one, we have 17 and 12. Well, we know that 17 is much bigger than 12, so we're filling in that blank. Our third one, we've got -3 and -10. Well, -3 is definitely the bigger number. -3 is the bigger number because it's closer to 0. And then lastly, our fractions. Don't we love fractions? 1/2 is bigger than 1/3. So that's just reading it as 1/2 is greater than 1/3. And -3 is greater than -10. And 17 is greater than 12. And 4 is less than 5. So if we kind of look at the problems underneath, we got to write the inequality given the description. So for our first one, we've got x is less than 5. X is less than 5. So x is less than, so it's not going to be facing the x, 5. Because 5 is the bigger number, so that matches up. For our second one, we have x is greater, so that's going to be facing that one, 4. X is greater than 4. Our third one, we've got n is greater than or equal to, so greater than or equal to, so we got to make sure we include that line, 15. And then our last 3, let's just write them out. So we've got x is, let's look and see. It's facing the x, so that means that x is bigger, so x is greater than 5. For the next one, we've got x is less than, but hold up, it's got a line under it, so it's also equal to, or equal, there we go, to 3. And then our last one, we've got x is greater than or equal to -2. So that equal to is just because it has that line under the inequality symbol. So hopefully this clears up some confusion. Go ahead and get started on your worksheet. But first of all, let's go to the front page and check off that booklet. Booyah, we did it. All right, go ahead and go to the assignment. If you have any questions, let us know. Thank you.